I thought today I would start by actually starting very early in my own career. My first postdoctoral research project was actually looking at the perception of ionizing radiation among medical workers in hospitals in the United States. My motivation in doing that was in part that a lot of concern at this period, this was the end of the 1970s, early 1980s, about nuclear energy seemed to be revolving around issues to do with radiation hazards. And what I wanted to do was to look at the perception of ionizing radiation hazards in a context that was perhaps less controversial, a less hot context, if you like, than was nuclear power at the time. So I went into hospitals to look at the extensive use of radiation in therapeutic and diagnostic contexts there, particularly also hoping that it would be a context where radiation was seen as actually serving a positive purpose and wasn't simply the incidental hazard of another technology. It was a fascinating project. Amongst other things, I discovered very important cultural differences between people working in research labs and those working in clinical labs. The culture of the clinical lab is that you must reproduce the same test over and over as exactly as possible. So actually sticking to routines, creating routines and sticking to them very precisely is an important cultural value of the clinical laboratory. On the other hand, in the research lab, the values were very different. The idea here was to make progress on research projects. And unlike the workers in the clinical labs, who were very careful to keep their radionuclides within the taped areas on the desk, in the appropriate lockers, to use only the hot sinks for disposing of radioactive materials, the guys in the research labs said things like, "I treat it like candy." In fact, one of them even went by the amusing sobriquet of 3 Mile Irwin, as his nickname. I went on from doing this work to the Oak Ridge National Lab, one of the US Department of Energy's research facilities in Tennessee. And initially they said, "We're really interested in the project you've just done because you can help us to understand why it is that people are perfectly happy to live downstream of one of the Tennessee Valley Authority's dams, but they're very uncomfortable about living close to one of TVA's nuclear power stations. And that if we can understand this, perhaps we can better explain to people why their concerns are misgiving." And what I said to them at the time was actually, I'm not sure, first of all, that I can do what it is that you ask. And secondly, I'm not sure it would be ethical. I don't think it's the role of the social sciences to engage in social engineering. But what I think we can do is to help engineer to the requirements of society. And I think one of the things we might be able to do would be to develop ways of characterizing technologies at early stages to understand what some of their social, environmental, economic, political implications might be, and how those might mesh with the existing values that people have. Subsequently, I've been through a whole series of controversial technologies with nuclear power, the internet, GM foods, and nanomaterials. And in the process, one of the things that I've observed is what I've come to call the novelty trap, which is that each time you have one of these new technological fields brought to the forefront, we are promised marvelous things. Nuclear power, energy too cheap to meter, the internet, the information superhighway, GM foods, we were going to feed the hungry, and with nanomaterials, we were going to beat swords into plowshares and produce wonderful kinds of technological utopian futures. What do we in fact get? We got the nuclear waste legacy, the digital divide, the flavor saver tomato, and nanomaterials in things like the socks I'm wearing at the moment, which have nano silver in them. But not only was, in a sense, the outcome of these technologies much more mundane than what has been promised, the promise of radical new capacities, new human powers through technologies, raised the questions of new risks. And time and again, the response on the part of the innovators was very consistent, which was to say, actually, this isn't new after all, we've been doing it all the time. Nuclear energy is just another way of boiling water to drive a turbine, to make electricity. The digital technology is really an extension of the telephone and the television and existing telecommunications. GM foods are just animal husbandry and crop breeding. And nanomaterials, well, you can go to the Royal Institution in London and you can see a big purple jar of stuff which was Faraday's creation of nano-silver materials. It's really just colloidal chemistry and electronic miniaturization. And I think this cycle of hype, reaction and normalization has been, on the one hand, extremely problematic, but on the other hand, it has also, I've suggested, been a form of informal technological assessment, a clumsy political form of technological assessment. And I do wonder sometimes whether the move towards public engagement mechanisms from social scientists and responsible innovation to some extent is a discomfort with the untidiness of the political world. I'm not taking a position on that, but I'm just raising that as a question as we go through the remaining material, and perhaps you'll come back to me at the end of the talk. Responsible innovation has been a long-standing concern. We've just heard about the excellent work that's been being done here in the Netherlands over the past decade. But in my experience, it goes back at least as far as the English sociologist David Collingridge's work on technology control in the early 1980s. And what Collingridge said essentially is when we have a new technology, ideally we would want to put the mechanisms in place for its responsible governance early in the technology, rather than wait until the technology has become locked in to a larger socio-technical system. Then we discover there's problems with it and we try to backfill, because that never seems quite to work. Since then, we've had constructive technology assessment from here in the Netherlands, our colleague Ari Rip and others, the idea of value-sensitive design, real-time technology assessment coming from Arizona State University in the United States, the idea from the UK of upstream public engagement, anticipatory governance, and more recently the idea of responsible innovation. So I want to say it's not an entirely new area. That's not to be critical, it's to say that these are serious and ever-present concerns that we're having to try to face up with in new ways, although we never seem to get quite a satisfactory handle on them. And I'm now going to focus in on one particular experience that I've had much more recently, which is that of being a member of the panel that was appointed by Britain's Royal Society to write this report on climate geoengineering. I was one of only 3 social scientists who, by definition, by the way, cannot be fellows of the Royal Society in Britain. Our Royal Society is for people in the natural and physical sciences only. But we were invited to join a panel of such fellows to consider the possibilities of geoengineering, and in 2009 issued this report. For those of you who are not familiar with the field, the definitions here: deliberate large-scale manipulation of the planetary environment to counteract anthropogenic climate change. And I want to start out by emphasizing 2 things. One is that what we're talking about here are not fully fledged technologies, they are not socio-technical systems that are capable of delivering the things that people imagine we might get from geoengineering. They are very much what we call socio-technical imaginaries. So these are very much the concept phase. There are pieces of equipment in existence which could be incorporated into geoengineering technology systems. There are computer modeling exercises which have been done about some of their effects, but we are not remotely near anything like a socio-technical system capable of delivering geoengineering outcomes. The second thing I want to emphasize is that geoengineering is a term that covers an extraordinarily wide range of heterogeneous technical practices. In that sense, it's very much like the idea of nanotechnology, which, if you remember, brought together things like microbiology, electronic miniaturization, molecular engineering, and so on and so forth. So we have a very wide range of heterogeneous practices being talked about under this single umbrella. Now, basically, for those of you who are not familiar with the field, there's 2 things you can do in the way of geoengineering. What's less well recognized, perhaps, is that there's 2 ways you can do both of those things. One of the things you can do is you can suck carbon out of the atmosphere and you can store it somewhere. The second thing you can do is to reflect some of the sun's energy away from the Earth by creating some kind of an umbrella or parasol effect. But there's actually two ways you can do both of these things. You can take carbon dioxide out of the atmosphere by enhancing Earth systems processes, or if you don't like it, you say tinkering with Earth systems processes. Or you can do it by traditional black box engineering, by making machines which will actually extract that carbon from the atmosphere for you, so that you can then either render it into carbonate rock, or you can put it down spent oil and gas wells at pressure. Similarly, there's two ways you can reflect the sun's energy. One is by putting sulfate aerosols into the stratosphere. Now you may say, why is that an Earth systems enhancement? Well, the answer is that volcanoes do it for us periodically. And indeed, when Mount Pinatubo erupted a few years ago, we had a detectable, sustained drop in the global average temperature of about 0.5 degrees for a couple of years. So actually, we have pretty good notion that that kind of thing can work. The fourth element, actually doing hard and traditional engineering, might involve putting space mirrors, possibly at the Lagrange point between the Earth and the Sun, possibly a large mirror, probably more likely actually a whole series of small mirrors, a bit like the kind of chaff that people used to release from aeroplanes to confuse radar, small reflective surfaces. That is actually the least talked about geoengineering option, largely because it's considered that the costs involved and the kinds of payloads involved and the level of control involved would be prohibitively expensive. So we don't hear much about that. Geoengineering, however, is not entirely novel. James Pollard Espy was known as the Storm King. He was the scientist who in the 1840s advised the US government that it should buy up woodlots across the United States so that it could set fire to them. And by creating very, very hot areas on the ground, his idea was that this would cause convection currents that would bring in cooler and more moisture-laden air into an area to create rain. This idea, by the way, was rejected by the Congress largely because of opposition from Southern senators who fear that in the event of the impending civil war, this might be used as a weapon against the South. Very early concerns about weaponization about this technology. There was also the notion of the rain follows the plough, and I've deliberately used the American spelling for plough here, because this was the idea that actually as you ploughed the Great Plains, you would release moisture from the soil, which would then evaporate, create rain clouds, which would then encourage further rain onto the plains, and the idea that in fact you would geoengineer the state of the plains through interfering with the weather system. There were various cloud seeding programs, particularly in the US from the 1940s onwards. And in 1965, the first ever report to the US president on climate change says nothing about reducing greenhouse emissions, nothing about what we call mitigation. It says nothing about adaptation. It is entirely concerned with things today we would call geoengineering. So this isn't an entirely novel field, interestingly enough. So then the question is, why now? Why are people thinking about this now? Part of it has been frustration with the slow pace of climate negotiations about emissions reductions. There is the idea that you might use these geoengineering techniques to shave the peaks off a warming trend, to extend the period that we have in which to introduce mitigation options. There's another concern, which is actually we have been making global warming signals stronger by our actions to reduce other forms of air pollution. We have recently introduced measures to clean up sulfur emissions from global shipping. That means that we are actually putting less sulfate aerosols into the atmosphere, which means that actually an aerosol ban which has been masking some of the existing warming trend is being removed, and we might want to do something to actually replace that, not by encouraging shipping to pollute at the lower levels, but by putting the sulfate aerosols into the stratosphere perhaps. If we want to tackle non-point source emissions, about 60% of the world's emissions are non-point source emissions. This makes them much harder to deal with. I put it to you that the jet aircraft is one technology. It's probably the only technology I can think of for which we cannot find a low emissions alternative that currently will deliver you the same level of service. And therefore having something that would deal with the emissions from jet aircraft in another way, such as sucking the carbon out of the atmosphere, might be desirable, and that's one of the reasons why Richard Branson has actually offered a prize for somebody who can come up with a good way to do that. But we've also had some other kinds of novel motivations. I have heard people say that they're not really interested in getting people to do geoengineering. They want to scare people with the idea of geoengineering into trying much harder to reduce their carbon dioxide emissions. And the other side of that, of course, is that there are people who then oppose doing any geoengineering because they're worried that actually people will become more relaxed about cleaning up their carbon emissions. There are others who see that there's a real commercial potential for new industries and services. And there's also the increasing recognition of the impossibility of meeting any kind of temperature stabilization goals that we have at the moment through mitigation alone. And you can see this in recent publications from the IPCC, UNEP, Friends of the Earth, Environmental Defence Fund, etc. And you can look at this graph here from the most recent assessment of the Intergovernmental Panel on Climate Change. And you can see that in fact the only scenario that keeps us below 2 degrees Celsius temperature rise is in fact that one there, which is RPC 2.6. RPC 2.6 includes very large amounts of what's called BECCS, biomass energy with carbon capture and storage. That's a geoengineering carbon removal technology. It would, by the way, have huge implications for land use and may have implications for biodiversity. So it's a non-trivial idea, but we can see that the IPCC essentially is saying you can't hit the 2 degree target without some kind of geoengineering. But I will emphasize that almost across the board, apart from a few nutters, and I use that word advisedly, is generally recognized among anybody who is seriously engaged with geoengineering research that at best it's a complement to, it's not a substitute for conventional adaptation and mitigation technology. There are many concerns. Is it technically feasible once you take it off the drawing board and the lab bench? Can you bring it to scale in a timely fashion? Could you get enough BECCS put in place, for example, in time to actually keep emissions down in the way in which the IPCC suggests? You're talking about building, in that case, for carbon removal, you're talking about building an industry on the scale of the fossil fuel industry in order to reverse engineer the fossil fuel industry over the last couple of 100 years. There's a question of timing. Can you build these things in a timely way? Costs and financing. You will often hear people say that putting sulfates into the stratosphere is cheap. The program costs of putting sulfate aerosols into the stratosphere are probably fairly cheap and probably a lot cheaper than conventional mitigation for the same amount of temperature reduction. However, of course, with all benefit cost analysis, it depends on how you bound the system. And if indeed you bound the system more broadly to include the broader environmental and social costs, already I've mentioned the possible biodiversity implications of biomass energy with carbon capture and storage. If you have other kinds of costs, such as you find that you've messed up the Asian monsoon, you've disrupted Asian agriculture, then your costs are going to look very different. What we found when we reviewed estimates of geoengineering costs is that they are entirely sensitive to the input assumptions. If you want to make any geoengineering technology look expensive, you choose the input assumptions that make it look expensive. If you want to make it look cheap, you choose the input assumptions and you bound the system in a way it looks cheap. So when you read articles which have titles like The Incredible Costs of Geoengineering, they are just that, they're not credible. Unintended consequences, I've already mentioned a couple, potential biodiversity implications with BECCS or disruption of the Asian monsoon as one possibility with sulfate aerosols, although that is contested, different computer models yield different results. There's the question of moral hazard and slip that I've already alluded to, this notion that somehow or other, if we appear to have some kind of a get-out-of-jail-free card, that people will try less hard at reducing their emissions. There's even the argument of what's called the slippery slope. I'll come to that in a moment. The idea that once you go down a little bit down the path of geoengineering, you're going to lock yourself in. Here is the idea of technical and economic lock-in. With technical lock-in, one example of that might be if you put your sulfate aerosols into the stratosphere and you continue to emit your greenhouse gases, relying on the umbrella that you've created to cool yourself down. Then you find, say, you've messed up the Asian monsoon, so you decide to stop. Then, of course, you're going to have a very sudden spike in temperature because of the accumulated greenhouse gases, which could be much more disruptive than having allowed yourself to reach that temperature in a much more gradual way. Economic lock-in. You might think that if you have carbon-sucking machines and you discover that there's some downside to them, you can just go and switch them off. Well, of course, technically you can. But remember, you've just created a huge new industry with vested interests in that technology running. And I will bet you that it will turn out to be institutionally, politically much more difficult to switch those machines off, given those entrenched interests which will have come into to play in the meantime. There's questions of public acceptability. We've just spent the last few decades telling people not to put sulfur into the atmosphere, not to stick stuff into the oceans, and now we are in a sense telling people, well, actually a little deliberate pollution is a good idea. So for example, the aerosols in the atmosphere, the pollution I should have mentioned a bit earlier when I was describing carbon removal technology. One of the carbon removal technologies is the idea that you would actually put iron into parts of the ocean where you've got iron deficiency with the intention of encouraging a plankton bloom. And then the idea is that the plankton photosynthesize, draw down the carbon, and then the plankton are eaten by fish and the fish poop sinks to the bottom of the ocean, use sequestered of carbon. There was a nice little experiment done by the Germans and the Indians on this, the first one. It worked in the beginning. They did get their nice plankton bloom, but unfortunately the plankton got eaten by jellyfish who have the wrong sort of poop. They have like floaty poop and the carbon therefore went back up into the atmosphere. But they're working on that. But the idea that we should be talking about deliberately polluting the oceans and deliberately polluting the atmosphere might be a hard sell for public acceptability. There are concerns about what's called the ethics of terraforming. There are those who cleave to a notion of some kind of natural ethics who simply say it is immoral for us to be consciously changing the earth. It's bad enough that we've been doing it unconsciously. There are issues around governance and regulation. Who would decide to implement these technologies? How would they be governed? And I think it is clear that it's these unencapsulated approaches, sometimes called the feral technologies, of putting things into the ambient environment, that are the technologies which cause the most kind of public concern. We have something called the geoengineering paradox to take into account as well, which is that the technically easiest and most fast-acting technology, which would be sulfate aerosols, would probably be one of the few things you really would need to have a global treaty in order to implement for climate change. I'm well known as somebody who's a skeptic of the idea that you need a global treaty for most things that we could do that would be sensible in response to climate change. I really cannot envisage putting sulfate aerosols into the stratosphere without one. Imagine for a moment that India had done some stratospheric aerosol spraying just before the floods in Pakistan a few years ago. You would never persuade any Pakistani politician or person in the street that the Indians weren't responsible for those floods. So even though there may be no scientific reason for concern, the potential security implications of people's concerns about disruption from the technology in themselves might make it very difficult. On the other hand, we currently could probably build these carbon-sucking machines under existing environmental and planning laws of countries, provided we were sequestering the carbon within our national boundaries. On the other hand, just think of the size of the industry you have to create before you're going to make much of a dent in the atmospheric concentrations of carbon, and then the long time delay it's going to take between actually taking that carbon out of the atmosphere and it having any influence on the climate. We've seen outspoken opposition to any idea of geoengineering. David Suzuki has described it as insane. David Attenborough has described it as fascist. There's an NGO called the ETC Group, which is famous, of course, for opposing almost every new technology that comes along the line, which has described it as geopiracy. And there is indeed some reason to have concern, although my concern is actually precisely with the scientific community that will be operating the technology and developing it. Paul Crutzen, who in fact popularised or repopularised the idea of geoengineering in a 2006 article in Climatic Change, was also one of the advocates of the idea of the Anthropocene. And this is a quotation from his 2002 article. And I do note that the daunting task that lies ahead is for scientists and engineers to guide society towards environmentally sustainable management during the era of the Anthropocene. Nothing there about democratic politics. On the other hand, I would also point out that there's nothing unique to geoengineering about this technocratic tendency. And some of you may recognise the two characters in this picture. You all probably speak German, but you actually don't have to if you just look at the iconography. This is, by the way, a cartoon produced by a German government agency, and it is fascinating to me that you have there the Nobel scientist, we all recognise him, who's with his head upwards proclaiming about what needs to be done, and the very contrite President of the United States with his head bowed saying he'll get onto it, sir. So I would argue that we already, in the conventional climate discourse, we're already facing this kind of problem of technocracy. To get back to the Royal Society report and the problem of governance, we concluded that the acceptability of geoengineering will be determined as much by social, legal and political factors as by scientific and technical factors. That was a very radical finding for the Royal Society. This report was almost not issued because all reports of the Royal Society have to be approved by its council, and there were many members of the council who felt that this was going beyond the Royal Society's remit of sticking to just doing the narrow technical scientific assessment. The report recommended the development and implementation of governance frameworks to guide both the R&D and the possible deployment of the technologies. And it's to those governance frameworks for R&D that I'm now going to turn. There's big controversy. Should there even be research, particularly into solar radiation management methods, particularly sulfate aerosols? Two well-known characters here. One is Michael Hume. Mike, the author of Why We Disagree About Climate Change. And his argument is we simply cannot know in principle enough about the way these technologies will behave in practice to responsibly implement them. And therefore, since we know that now, we should not even begin research. Indeed, our ignorance about what the implications of these technologies will save us from the folly of trying to develop them. And he says, quote, the simulation models upon which aerosol injection technology would rely are like calculative cartoons. Now, David Keith of Harvard and Calgary disagrees, and he has laid out a program whereby he suggests that ignorance can be reduced by carefully constructed research, that we have actually quite a lot of information based on volcanic eruptions, based on computer modelling, etc., etc. And he believes that not to research is to remain ignorant of our ignorance. We have a strong empirical basis, quote, on which to assess these risks. I don't know who's right, but I would simply flag that there is that kind of level of disagreement in the scientific community. There is concern about the slippery slope I mentioned before, the idea that if you actually even start to do research on these topics, you normalise them. As social scientists, I've just completed a 3-year project funded by the Economic and Social Research Council in the UK on governance of geoengineering research. And one of the questions we asked ourselves is, even as social scientists researching the potential governance, are we normalising a technology? Are we making it thinkable, something that some people at least think ought not to be thinkable? It's a reasonable question. However, it's a very strong claim to say, as some have done, once the first step has been taken, development cannot be stopped. We know that patent offices are actually the graveyards of dreams. Most patents are death certificates. We spent 30 years and close to $100 billion on expenditure on fast breeder reactors. Show me the fast breeder reactor. So there is some empirical evidence that suggests that the slippery slope argument is perhaps overstated. There are a number of important dilemmas of control for research. I've already said we're talking about socio-technical imaginaries. What's the object? What's the object of regulation or of governance or of control or management for geoengineering? And there's been a fascinating definitional politics that's been going on, trying to define different technologies into the category and out of the category. So, for example, at the 2011 Asilomar conference in California, people involved in forestry were very keen not to be classified as doing geoengineering because they were concerned that it might subject them to additional regulatory burdens. On the other hand, the biochar people were desperately trying to get into the category of geoengineering because they thought that this would be an opportunity then to open up research and development funding for their particular technology. That definitional argument continues with the latest reports from the National Academy of Sciences on geoengineering, which has split the topic into two separate reports, one on solar radiation management and one on carbon dioxide removal, arguing that they have nothing in common and that carbon dioxide removal is really just mitigation. It's a form of hyper-mitigation. I actually disagree with that, by the way, because I think if you were going to contemplate doing solar radiation management using sulfate aerosols, given that termination problem that I mentioned earlier, the danger of a sudden spike, you would want to have an exit strategy from that technology. And the exit strategy that suggests itself would in fact be carbon dioxide removal. So if you think about a socio-technical system of geoengineering, it might well involve, on the one hand, doing some solar radiation management and then developing a capacity to take carbon dioxide out of the atmosphere as a way that you can bring that phase to a close. So the notion that they are completely separable and should be thought of separately, I think is a questionable one, but I think it's a very important one to notice from the point of view of the political implications for the people advocating the various technologies. We also have this whole question of distinguishing geoengineering from basic science. If I spray some sulfate into the atmosphere and say, I'm just doing this because I'm interested in studying how clouds form, I may be doing exactly the same experiment as somebody who says, I'm doing this because I want to understand geoengineering. Does it make a difference how that experiment is defined, or is it the atmosphere of the activity of experiments in the atmosphere that we're really wishing to govern? Who should govern and regulate? Should it be self-regulation? A recent conference in Berlin just over a year ago, it was very clear that there were strong views on the parts of some scientists and engineers that it was their prerogative to manage their own technological activity. And they were offended at the idea that anybody should think that they would not exercise appropriate responsibility in developing their research projects. And there were others, on the other hand, who clearly were expressing a high level of concern at that idea, and indeed didn't want any geoengineering to happen until there was a global treaty in place, which will put it off a very long time, given how good we are at getting global treaties on climate stuff, right? And then finally, there's this desirability of locking in, avoiding locking in rather, to both into an inappropriate or unacceptable technology, but also to an inappropriate governance architecture that is either inadequate to deal with that technology as it develops, or indeed prevents the technology from developing that otherwise would be socially useful. We don't have a completely blank slate. National governments already regulate activity on the ground within their borders. I've said, if you are interested in doing experimental work for carbon dioxide removal, there are existing regulations with respect to environmental impact and planning, which you would have to conform to. There are customary international norms imposing duties of cares on states not to damage neighbours. There's no, as yet, international law of the atmosphere. The London Convention and Protocols has been developing regulations for experiments in international waters, but there is still this vacuum, if you'll forgive me saying so, vacuum for geoengineering activities in the atmosphere. We have no law of the air, although the Convention on Biodiversity has expressed some interest and appetite to assert wide jurisdiction. Of course, the problem there is A, the US is not a signatory, and B, they can only exert that jurisdiction if there are impacts on biodiversity, not for other kinds of impacts. So the question is, do we need a fully articulated architecture before we go forward with research, and is one even plausible? What would it have to have? What characteristics would it have to have? It would have to recognise this tension between top-down anticipatory and bottom-up emergence approaches to governance. It would have to be implemented through existing national structures for R&D funding and regulation, or top-down as part of a global comprehensive architecture. So what we set out to do was to establish a few guiding principles that would be applicable to a highly heterogeneous range of technologies and establish key societal goals. These principles were not based on assessing the technology, they were based on the 20 years plus experience of the people who were involved in formulating them with socio-technical controversies to try to tease out what we thought were the things that cropped up time and time again. What were the social non-negotiables about a technology that we would want to address? Those would necessarily have to be high level because of the heterogeneous nature of the technical systems involved. And then we would propose that underneath that you could require the developers of the technologies themselves to propose flexible technology-specific research protocols which would take into account the particular techniques that were being developed and the stage in which they were the stage of development in which they were. So we came up with 5 principles, the Oxford Principles, which we submitted to the UK House of Commons Science and Technology Committee's inquiry into climate geoengineering governance. And you can see them here before you. I don't have time to tease all of them out in detail, but basically the idea that geoengineering should be regulated as a public good and in the public interest, that there needed appropriate public participation in decision making. That could be different depending on the level at which of activity you're proposing. It would be perfectly reasonable, for example, in conducting an experiment like the Spice Balloon experiment, which I'll come to in a moment, which was proposed to be conducted on a Cambridgeshire airfield to conduct people in the local neighbourhood. I don't think you have to ask people in the People's Republic of China for permission to do that. On the other hand, as you start to have the scale of your impacts increase, you have to find ways of engaging broader publics. We were very keen on this notion of disclosure of geoengineering research and the open publication of results, not least in part because one of the small group of people formulating these had extensive experience in the medical field, where drug companies are notorious for not publishing the results of failed clinical trials. And we wanted to be sure that all the information was out there and publicly available. Fourthly, there should be independent assessment of impacts. You could do a NASA-style red team, blue team kind of project or some other mechanism to do that. And thirdly, that the governance arrangements needed to be clear before deployment, we said at this stage, and subsequently we've elaborated on that and say the governance arrangements for each stage of research and development also need to be clear before you go on to the next stage of research and development. Underlying those, as I say, technology-specific protocols for each technology that would enable regulators to address specific issues. And that you would then have a series of stage gates that basically you would, if you were a scientific and technical organisation or a funding body, you would give permission for a phase of research to the initial phase of research to be carried out, conditional upon the proposers specifying how they will implement the Oxford Principles for that stage of research. And then once that stage is completed, before permission is given to go on to the next stage or funding is given to the next stage, they will then have to say how they will then implement the principles of that further stage of research in concrete terms. So basically what you're allowing here is the regulatory structure, the governance structure, to co-evolve with the technology step by step, rather than trying to anticipate what the final technology will look like, because you'll be wrong, and to avoid having the negative effects of being overly constraining. Nature was critical in an article of our proposals, which were, by the way, accepted by the British government. Nature said that this was too general. They could apply to any set of emerging technologies, and as one of the authors of this other report of the Royal Commission on Environmental Pollution, which came out shortly before the geoengineering report, my response is, why not? Seems to me like a perfectly sensible set of proposals to actually to apply to potentially controversial emerging technology. Now, I've already described the stage gate process, so I won't go through that again. But I will move on to discuss the SPICE experiment. Some of you may have heard of this. SPICE was a project, sulfur particle injection experiment. This was a part of a larger program to assess sulfate aerosol as a technology. And as part of that program, it was proposed to launch a balloon on a 1 kilometre tether over a Cambridgeshire airfield to do some engineering tests for how such a balloon might behave if you had a 20 kilometre high balloon the size of Wembley Stadium, which could be used as a way of continuously introducing sulfate aerosols into the stratosphere rather than taking them up in aircraft. This proved controversial. The Research Council said, indeed, you will have to go through a stage gate approval before we will allow you to conduct this experiment. In the first stage gate meeting, the proposers were told that they would have to go back and do more public consultation, that they hadn't consulted adequately with the public about the technology. And they were in the process of doing that when it came to light that two of the scientists involved in proposing this experiment had already taken out patents. They'd already obtained intellectual property in the technology. And it was on that basis that Matt Watson, the head of the SPICE project, decided to cancel the project, the balloon project. And in doing so, he explicitly invoked Oxford Principle 1, because he said that this private acquisition of property rights was not in the public interest and the public good. He also recognised the inadequacy of the public engagement that had been performed, Oxford Principle 2, and the absence of explicit governance arrangements for outdoor experiments, which was our Oxford Principle 5. So we actually can see how these principles have actually been translated in a practical case. Many people refer to this as the SPICE balloon debacle or the SPICE balloon disaster. I refer it as the SPICE balloon success, because I think it showed how this model of governance can actually be implemented successfully in practice. It doesn't guarantee it, of course, but it shows that it can. Subsequently, colleagues at the IASS in Potsdam, Anna-Marie Hubert and David Reinweich, have produced a draft code of conduct for responsible geoengineering research, developing the idea of the Oxford Principles and the technology protocols even further. They base this to some extent on the Food and Agriculture Organization's Code for Responsible Fisheries, and it's now available. You can go and look at it on the web, and you can see, in fact, how it takes this line of thinking forward. In closing, I just want to raise a few questions. Firstly, is geoengineering the right object? I've already alluded to this. I've talked about the active definitional politics of opting in and opting out. Do we really want to say that carbon dioxide removal is just mitigation, particularly in the light of the potential biodiversity impacts of a technology like BECCS? Does intention matter? Is the real concern the potential detrimental effects of the activity, or is it with the motivation behind the activity? Is it, in fact, that geoengineering per se shouldn't be the focus for governance, but experiments in the ambient air on some kind of scale or another? I don't know. I'm just raising these as questions. We have national government regulation for land use, but we don't have it for non-land-based research, and particularly in the atmosphere. So I think I would argue that the Oxford Principles have proven to be robust and useful, and they've been used. The stage gate model was effective, but norm building is essential, and we're in that stage of norm building now with the code of conduct that I just mentioned. But I think some of the things that geoengineering, we should think about, not just about the implications of geoengineering for society in the sense of what are the technical or climate implications of geoengineering, but what can we learn from thinking about geoengineering for responsible innovation? Firstly, is it really has highlighted the extent to which technology development is non-linear, and we're trying to assess already technologies at an early stage where we really don't know what we're assessing most of the time. And this has actually given rise to a problem for the notion of upstream public engagement and upstream technology assessment. Because in fact what we end up doing is ending up in a situation where we have a choice of imaginaries ranging from here is a technology that could be very useful to one that could be extremely dangerous. And you know, basically, how do we characterize it in a way that's realistic? The technology developers themselves here have been those who have called in the social scientists. I think this is really important to emphasize. This is not Dr. Strangelove. This is, in a sense, the scientific community saying, okay, you social scientists, you've been telling us for years we should be doing this upfront assessment, come in and do it. And there have been more papers published in the last few years from social scientists on geoengineering than there have been geoengineering technical papers. So there's a prudent concern over governments. And the technologists are actually holding back from doing anything outside of the lab. That actually starts to limit our social science research, because in fact we then now have a lack of specificity about the technology it is that we're trying to make an upfront assessment of. And there's a lack of broad public engagement. We've tried to get the public involved, but for the most part the public isn't interested in engaging, because they either see this as too science fiction or it's too vague and undefined for them to get to grips with. So the question here as to whether we actually have a research impasse. Can the social sciences go much further than we've gone already without the technology developing? And the technology doesn't want to develop until it gets some kind of an answer from the social scientists about does it have a social license to operate. So finally, what can this geoengineering discourse do for society? I think it's fascinating that the values in these debates at this moment are unusually explicit. There's very little science to hide behind. And that's unusual. Usually we only get controversy once there's enough science there that people can hide their values behind technical claims, rival technical claims. And I think that's a very interesting stage to be at. I don't know how long it's going to last, but it does make it interesting. The discourse itself, I think, is an opportunity to explore representations of nature, debates about the good society, the role of technology in our lives, and so on and so forth. And I think that is something that geoengineering is doing for us, regardless of whether it actually ever comes to fruition in material terms. What can geoengineering and the debate about geoengineering governance teach us about the governance of other global emerging technologies?
Great, thanks very much.
Ulrike Feld, University of Vienna. I have a couple of questions actually. When I first got interested in the question of geoengineering, I was totally struck by the fact that in Austria, for example, this is a non-debate, a total non-debate. I checked out yesterday evening because I was interested in how many kind of articles would be in media, high-end media, and you can count them on two hands. So this is a non-debate. So my question was like, who leads this debate? And so whose values do get kind of expressed in these debates if they are led by a couple of large countries while we inhabit this planet? I suppose also smaller countries do so. So I was wondering if that has been a topic.
Sure. Yeah, most of the work on geoengineering is published in English, of course. The three countries which have conducted most of it are the United States, the United Kingdom, and Germany. And if I were to, and this is a very, very rough caricature that I'm just going to offer here, I would say that in general, the interest in the United States is more in how can we do it. The interest in Germany is how can we learn about this so we can stop the Americans from doing it. And I think the interest in Britain is somewhere in between, which is, this looks like an interesting idea, could we find out a bit more about it first before we make up our minds, please? Kind of like we were about the European Union. So I think there are those very crude kinds of things. There has been concern expressed about other countries. Some people have expressed concern about China developing geoengineering. I have to say, in a couple of visits to China to explore this, I've known of only really one Chinese group trying to propose geoengineering research. They were turned down twice for research funding. I believe they've just obtained some research funding to do this, and that is a mixed social science and natural science grouping. For the most part, what the Chinese were telling us when we went there was, oh, our idea of geoengineering is mitigation technology. On the other hand, China has an immense weather modification infrastructure. I don't have the numbers at my fingertips, but literally thousands of cannon and rocket launchers that they use to put mostly silver iodide into the air at much lower altitudes than you'll be putting sulfate aerosols into the atmosphere in order to disperse storms, particularly hailstorms, and to initiate rainfall. It's not too much of a stretch to imagine that should the People's Republic of China develop a conviction that geoengineering is a promising line to take, that they would be able to very rapidly move to a level of implementation. There's that. The other concern that people have expressed is the idea of a rogue individual or a rogue state doing some sulfate aerosol injection. I discount the rogue individual because any state would be able to close down an individual's activities. As to a rogue state, I think it's highly unlikely that it would be China or the United States for various different reasons largely to do with their international reputations and security positions. The most likely scenario I have proposed is that in fact a small island developing country might well allow for some aerosol spraying from its territory as an act of global civil disobedience to draw attention to itself, in the hope that indeed the US and other countries will step in and close it down, and then they could say, you've taken away our last lifeline. And so one could imagine that as a form of political protest that could actually be quite potent. I haven't received any phone calls from the heads of small island developing states to ask me to enlarge on this idea, but it seems to me that that's probably the most credible.
Yeah. Sorry. Yeah, two questions. Lotte first and then you, sorry. Yeah, Lotte, go.
Yeah, I'm waiting for the microphone. So, Lotte Asveld, Delft University of Technology. Thank you for your interesting talk. You mentioned these 5 Oxford principles and how in the case of the SPICE experiment, apparently the first principle was not being respected because of the patents. And you were also suggesting that these Oxford principles might be applied to other emerging technologies. So I was just wondering if the patents are a problem with in line with these Oxford principles. What would this imply for the commercial parties and their involvement in new technologies?
Yeah, that, interestingly enough, was a question that the House of Commons Science and Technology Committee immediately raised with us. And what we said was, firstly, we recognise that the aerospace and defence industries are inevitably going to be involved in developing these technologies. They have the technical capacity and capability that we would need, and we couldn't develop them without their engagement. What happens at the moment with defence contracting, and by the way, defence is a classic, possibly the classic public goods example in standard economics, in the sense that we all enjoy the benefits and we can't opt out, and my enjoyment of it doesn't diminish your enjoyment, etc., etc. What happens there is that, of course, governments specify technological capabilities that they want of defence contractors. Defence contractors then form consortia, they come up with proposals. Eventually, the technology is produced. The defence contractor is allowed to have patent rights in parts of that technology, but they're not unrestricted, and they can't then go and sell the technology they've developed to anyone they like. They can only sell it to somebody who the government has approved of, so on and so forth. So you can have a system where you are already today providing high-tech public goods technology in a way which fits the model of the public good and the public interest. And I think it would be unrealistic to say, you know, it would all have to be open access.
One question over there.
Hi, Ansgar Kuhne, University of Nottingham. I wanted to continue on a bit on this topic of the role of, I guess, industry, and picking up also on what you mentioned at the end, concern of how much are these issues actually taken account of outside of the academic community. So with patents being one of the issues, and you mentioned Branson being interested in this competition for doing some kind of geoengineering. How much does industry pick up on the issues of like the Oxford Principles and those kinds of questions of thinking beyond the profit potential of these kinds of technologies?
At the moment, I'm aware of, so far as I'm aware, there's very little interest or active interest being shown by large industrial organizations in any aspect of these technologies, except of course for something like BECCS, because it's all part of a generating technology, but even there it's relatively limited. The companies that are involved in research are actually, to my knowledge, all small university spin-offs. So it's basically academics who are thinking about developing the technology outside of the university a bit. And Jose was also.
First, and then Jose. Yep.
Thanks a lot, Raffaele Hillerbrand from Karlsruhe Institute of Technology. I was wondering whether sometimes not very indirectly funding bodies gives the wrong incentives for scientists to choose a topic, because I know that the UK has a very large fraction of climate science devoted to climate engineering, and that...
I don't know where you get that impression from.
But maybe I continue.
I'll let you finish your question, however.
Climatology is part in the Royal Academy of the Engineering Department and not of the Science Department. And I was just wondering, you disagree with this percentage, but maybe the second one is just a fact. And maybe if you think about responsible innovation, this would not only mean to look at the technology itself. You mentioned socio-technical system, that when we do responsible innovation for geoengineering, we have to take a really broad look and also include institutions, funding organizations. And in case so, you mentioned it a bit, how this could look like, this responsible innovation, including funding bodies, including institutions.
Right. Let me correct your initial misapprehension. In this report, we recommended that the UK government should spend £10 million a year for 10 years. No, sorry, £5 million a year for 10 years. Over the period since it was published in 2009, the total of UK Research Council funding has been 5 million. And in fact, the authors of this report are currently in the process of drafting a call to the government to actually heed the recommendation that we originally made. So in the UK is spending less than £1 million a year on geoengineering research, and I would say that at least a third of that has been on the social sciences. So the notion that we have a large proportion of our climatologists and climate scientists looking at geoengineering, I'm afraid, is incorrect. I think we have a small group of people who are very productive in terms of papers and presentations. On your second point, yes, I think if we're talking about what I was trying to do here was and what we've been trying to do all along with the Oxford Principles and this stage gate process and the idea of developing professional norms, is to develop a framework which can be implemented by individual scientific and technical organizations. So it could be universities themselves, it could be people running labs, it can be the funding councils, it could be the government regulatory bodies. One of the things I think we wanted to do was to be able to propose elements that we felt gave some reassurance that things were being done responsibly, but in a way that enabled the maximum flexibility for different countries who have different scientific governance traditions, different regulatory structures, different political systems and so on, to be able to incorporate them into their existing frameworks rather than have to develop something completely from scratch. And that was the purpose. So yes, I think integrating them, these efforts and these different institutions is something that's highly desirable, but it's not something for which you can lay down a single template. That is part of where I started out at the very beginning when I said we have clumsy, ungainly ways of doing technology assessment because it's a political process.
José van Eindhoven, as you already know, nowadays Erasmus University Emeritus. First an observation and then two questions. Half a year ago there was a presentation on geoengineering at the AAAS conference in San Jose. Ted Parson was one of the presenters, and it feels as though you are more positive about going on with geoengineering than they were. I don't know whether you know the report that came out, the National Research Council report in the US about half a year ago, of which a group was responsible, of which Granger Morgan was one of the group of the board that wrote this report. That's one observation. The other observation is that I think that you are more social science, there are more social scientists involved in this Oxford effort than in the American one. And the third, that's almost two questions, but I also see here a new example of the Collingridge dilemma. You seem to look as though we are knowing which is the right way to go, but from the example, a recent example like nanotechnology, where IRIP was involved in the Netherlands, I see what happens, that they did analyses, but on nanotechnology in a certain area, whereas now with the Health Institute in the Netherlands, RIVM, I see that they are now much more involved. The problems are much more with the fact that everything we put on our face is having nanotechnology. And we didn't see that. And then the director there, the Director General, said, well, so the TA was bad. I said, no, this was an example of the Collingridge dilemma. So, well,
You brought that up, eh?
Well, actually, I'll start at the end, because I was one of the authors of the Royal Commission Environmental Pollutions Report on nanomaterials, and this came out 2007, I think. I'm a bit hazy on the date, I'm sorry about that. And our concern there was exactly the potential for nanomaterials to enter the human body through routes that had not been considered by the standard methodologies, and particularly the blood-brain barrier in the area up here, and so on. So, interestingly enough, you can already see that in different national contexts, the emphases, perhaps, of technology assessment are different. And one of the things that might be very useful would be some kind of observatory which would actually keep an eye on what's going on in different places and seeing why is it that they're concerned with one aspect of a technology in one country whereas not in another. There's been huge furore, as you know, about silicone breast implants in the United States that has been non-existent in the United Kingdom. And you would think that if the rates of problems that have been reported in the US, you would expect that to have been reflected also in the UK, but it hasn't. So you know, these are, as we know, complex socio-cultural, political kinds of matters. As to my own orientation here, I'll be completely straightforward with you. I am not in favour of geoengineering. I'm not opposed to geoengineering. I normally have a lot of sympathy with Mike Hulme's views of the world. On this, I disagree with him. I disagree with him for two reasons. One is I don't think I am satisfied that I know enough yet to rule out the possibility that some good may come from this. And secondly, just as he argued in his Why We Disagree, that the debate about climate change provides wonderful opportunities for society. I think the debate about geoengineering also provides wonderful opportunities for society. And I'm always been surprised that Mike has not applied the same logic to geoengineering as he has to the climate debate more generally. As to, if you want a prognosis, and this is a purely personal view, it has no scientific status whatsoever, my personal view is we will never end up using these technologies, but for very different reasons. I think we won't end up using sulfate aerosols because I think the politics of getting a global agreement on them is just going to be too difficult. And I don't believe that we'll do it without a global agreement. And whereas the carbon removal technology, I think, doesn't present those kinds of problems because we can, as I say, do them under national legislation, the sheer scale of investment that would be needed, the financing that would be needed, the human resources, the materials involved in building an industrial infrastructure on that scale in a time that's going to affect global temperatures by the end of this century is something I find very, very difficult to have any credence for. So I'm actually sceptical we'll do either. And from that position of skepticism, I still think a limited amount of research is still justified because I think where there is sufficient ignorance as to make that a reasonable thing to do, not to divert vast amounts of funding away from other climate-related research or implementation activities. And I think something like the Royal Society's figure of £5 million a year is a perfectly reasonable research budget on which to do that. With respect to whether or not I am more optimistic about geoengineering than Granger or TED, I don't know. It depends what you mean by optimistic. I think they're more optimistic it's going to happen and it's going to work than I am.
Okay, thanks. So final question, yes, a quick one, and then.
Yes, my name is Martine Vonk from Saxion, University of Applied Sciences. What I hear in your story, and I think we all agree, is that all these kind of issues we have to face from several points of view and from several sciences. And I wonder about I ask about your experience about, do you also see a real interdisciplinary way of research coming? I mean, we can learn from each other, but we can do it separately. And I think we really need an interdisciplinary and that we influence each other's kind of research. And do you see that happen, or is it still something?
Yeah, I mean, interdisciplinarity is something that I've sought to pursue throughout my professional career. In this instance, I think there is quite an interesting story, which is there in the UK there were 3 major projects funded by the research councils. The first 2 were funded by the Natural Environment Research Council and the Engineering and Physical Sciences Research Council. And they were the result of a process called a sandpit. I don't know if you're familiar with this idea, but basically a group of people applied, a subgroup were selected and taken off to a hotel in Devon, I think it was, for a few days, and they were told to play nice together and come up with research proposals. And from that process, two proposals emerged. One was the integrated assessment of geoengineering programs, the IAGP, and the other was the SPICE, which was, and I always get this wrong, the sulfur particle injection something, I can't remember what the other part were. And those, in the IAGP, there was a tiny smidgen of social science. There was none in the SPICE program. The third program was the one that I was the PI for, which was called the Climate Geoengineering Governance Program. And that project was funded by what's called the responsive mode. And the responsive mode is basically you just go in and you put your proposal in alongside a lot of others and on different topics, and they're peer reviewed and supposedly good ones pop out the top. And we were funded under that mode. We had an interdisciplinary group of social scientists. The other two were interdisciplinary groups of natural scientists. But they were separate projects. During the process, actually we started talking to each other quite a lot. And by the end of, they all came to an end roughly at the same time. We actually had joint presentations of the results at the Royal Society. We had a joint press conference. We have done joint press releases and so on. And one of the things that we have said to all of our research councils in the UK is here is interdisciplinarity being built from the bottom up, which is actually the only way it's ever going to work, because you can't build it from the top down. So I think, yes, I would argue that it has done. I still think there is a problem at the moment, which is, I think that, to put it crudely, the social science has now outpaced the natural science and the engineering. And that's my problem, is I don't feel I can go much further with this until there is more substance there to get to grips with. And I'm not sure that the scientific and engineering community at the moment feels sufficiently reassured by what the social scientists have told them that they feel that they can take even tentative next steps without running into serious opposition and trouble. And the research councils have been very conservative with respect to their thinking about funding further research. Thank you.